Welcome back to the Introduction to Animation Nodes tutorial series. If you came here directly, you might want to start at the beginning. All the info and links are in the video description below. In this video, we will learn about groups and loops. Okay, so let's just create some objects in our scene. A cylinder, a UV sphere, a monkey, maybe a torus and a cone, and then just a simple plane. Okay, so we have different objects in our scene. Now let's try something new. Let's select all of them with Shift and then hit M, new collection, call them objects and hit OK. Now all of my objects are in this objects collection. Now in animation nodes, I can simply go to object collection, get a collection node, which gives me this data type called collection. I'm gonna pick my objects. What can I do with a collection? I can do collection info, plug that in here. And then here I have the objects of my collection. Now let's say I want to use animation nodes to show how many vertices each object has. Vertices sounds like mesh info, right? So let's get a mesh input and plug all those objects in here. And you can see that doesn't work. This is a list of objects. It's transparent. This is a single object, and this mesh object input node cannot handle lists of objects. So we need to create a loop. A loop, if you're familiar with software development, a loop is just a subprogram, a piece of code that is being executed inside of a loop. So maybe 100 times, 1000 times. In this case, we have 1, 2, 3, 4, 5, 6 objects. So this is a list of 6 objects, which we can verify by plugging a viewer in here. Yes, it's a list of 6 objects. And we're going to create a loop that executes the code inside of the loop 6 times, so once per object. How does that work? Well, we have a menu here with Shift A. This comes up, and then we have subprograms, group and loop. Group is basically just putting a whole bunch of nodes, of animation nodes, like a certain setup, a node tree inside of a group, just like you would with the group in a material node setup. So group is basically, you have inputs, you define what kinds of inputs does my group have. Maybe you have a list of objects, which is what we're going to need. And then you create an output node by clicking here. This is now your group output. And inside of this group, you can do stuff with this object list. I don't know, maybe get length of object list. And this is going to be the output of your group. So basically now you only grouped a single node. Kind of boring. Maybe we should do something with it. I don't know. Makes no sense, but let's multiply the length by 10. This is our group now. We can also name the output here. Call it super. Name the input. Call it objects. And then we can select this node, the group input, hit W, create invoke node. And now we have a subprogram, a node. We created a node just like these nodes are. We have our own node now that has an objects input, this guy, and it has a super output, this guy. And if we plug in a list of objects and the viewer in here, we have 60 because we have 6 objects multiplied by 10. Of course, this is a useless group now, but you get the idea. You put stuff inside of a group, maybe a very complex node setup, and then you have a node, just like all the other nodes in animation nodes, that you can use and reuse. So if you have this kind of operation, like 2, 3, 5, 10 times inside of your node tree, just put it in a group like this, and then use that invoke subprogram node 10 times. But that's not what we want to do here. That's the group. We actually want a loop, and the loop works. No, not a loop viewer. We want a subprogram loop, and the loop works almost the same. We have the loop input node that we can add to our node tree. We can create a new iterator or a new parameter. What does that mean? An iterator is basically a list of things that this loop will loop over. And then you can also add parameters to your subprogram. This can be anything. That doesn't have to be a list of anything. The loop input node also gives you an index that you can use inside of your loop, and the iterations, which is the length of the list of stuff that you are plugging into your node. And we need a generator output. When you click on this plus here, you have to define what does this loop create? What's the output of this loop? So let's start at the beginning. We know that we want our mesh input node inside of the loop because it can only handle a single object. We need an object list as the iterator input. Inside of the loop, inside of the loop, we have a single object. So this now gets executed with the first object of a list being plugged into the loop. Then it gets executed with the second object, and so on. Okay, if we want to our loop to output the objects that we're plugging in, we can create an object list output generator output. Our loop actually is not going to have any output. It's just going to do something, but it's not going to output anything, so I don't need an object list output. What I do need though is an invoke node. So this loop is going to do stuff to each single object, but I have to plug my objects in somewhere. I need an invoke node. So select the loop input, W invoke node gives you this node, and you can plug the objects in here now. Okay, now this makes more sense now. We have a list of objects, plugging it into our subprogram. Inside of our loop, which takes a list of objects, we only ever get a single object. So this is now being executed for each individual object. Now, how do we get the amount of vertices inside of the mesh? Well, that's just the length of this vertex location list, right? So we need a list, get length of this, all the vertices inside of the mesh. Now we know how many they are. Right now, you know we have viewers, a viewer, a 3D viewer we've used before. There's also a loop viewer, and this is good for visualizing, for showing stuff that's happening inside of a loop. If you don't just have a single value that you can visualize in a viewer, or 3D information you can visualize in a 3D viewer, if you're actually trying to visualize something or debug something inside of a loop, take the loop viewer. So let's plug our get list length thing in here. And the loop viewer, the way that works is it needs to show 6 different numbers now. How is it going to show this? Well, simply by hitting plus, creates a text output basically, so a text file, and it's going to write the output of this node here into this text file, 1 per line. And by hitting this little icon and then picking which direction you want to show this loop viewer output. So let's just show it on the right here. It opens this text output file, and it's going to run in here and show us the output of this loop. Okay, now let's quickly check execute node tree. So if I hit execute node tree, we get 64, 482, 507, 4. Well, 4 is just this, obviously. And then the other objects in our collection have these amounts of vertices. And we see that because of our loop viewer. So that can be very, very helpful. The loop viewer, again, just creates 1 line for each iteration of the loop and shows whatever you plug into it. Okay, so this is already working. Our loop is working for each object. This loop content here is being executed. We're just getting the amount of vertices of each object. Now we want to do something with this. Let's create actual text objects in our scene, showing how many vertices each object has. How do we create a text object? Let's see. We have this data type text here, and there is a text object output, surely somewhere, object output. Yep, interesting. So we're gonna need, inside of our loop, we're gonna need 6 text objects. How can we create 6 text objects? We have to do that outside of the loop. We can't put an object instancer inside of a loop, so let's do it outside. Create an object instancer, maybe create a single text object somewhere. Where is it? Text. Okay, so we have one, hide it, plug that text object in here. How many instances do we need? Well, same trick, we just take this list, plug it in there. Animation Nodes creates a get length node for us. So now we have 6 text objects, 1 per object in our collection. And we want to plug those texts also into our subprogram so that we can assign the text to it. Which means we need another iterator because we're plugging a list of objects in here. So again, an object list. We should actually name these. So here we're gonna plug in our texts. And here we're gonna, we can leave that as objects because that's what we're plugging in here. Now we have this text input on our invoke subprogram. We put our texts in there, and now we can access these inside of our loop. And what we want to do is, for one object, we want to access one of the text objects. Oh, by the way, you might have noticed that everything that is inside of a loop also gets a different color. So this blue loop here that is being invoked here, this is all inside of this loop. If this node is not part of this loop, it's gray. When it's inside of the loop, it's blue, which is very nice because it makes it clear that this all belongs together into this subprogram. Okay, here we have the length, here we have the text objects. So for the first object in our collection, and we have the first text object that we want to assign a text to. We can assign a text. How do we convert a number into a text? Maybe there's a node for that. Text convert to text sounds good. Plug in a number, plug the text in here. And what do we have? What does it look like? Oh, we already have a text that's showing something. Cool. Now what can we do with this text? We can extrude it, give it some thickness. And we can also see that we're jumping around here. That's because we have to enable copy full object and deep object. So we're actually getting different instances, not different instances. We're getting actual objects. Deep copy doesn't instance the object. It creates a new full-fledged object. That's what we have to do here. And they're all at the same location, which is kind of stupid. Let's fix that. Of course, we can do that inside of our loop. This text object, let's also transform this text object. How do we do that? Well, we need the location of each of these objects. So object transform input, the object location. And we want to transform the output of the text. So object transform output, this text location, where these guys are. Okay, that looks cool already. Now how do we shift this or lift these texts up to be above the actual object? I need to transform this vector somehow. If I take a vector offset and plug it in here, we realize that this offset vector always takes a list and creates a list. That's kind of complicated for what we want. Let's hook this back up and instead do vector transform. Yep, that looks good. Transforms a vector using a matrix. And all we really need is a very simple matrix. So we can just compose one manually for the location for the C and lift this up like that. Now where's my original text? I want to hide that. What is happening here? Objects, there's something in here. Oh, my text object is in the objects collection. I don't want that. I just want the cone, cylinder, plane, sphere, Suzanne, and torus. Yeah, that looks good. Okay, let's execute. So we have a subprogram. We're plugging the list of objects of a collection into that subprogram. We're also creating the correct amount of text objects. We're plugging those into the subprogram as well. And inside of the subprogram, we are counting the number of vertices of each object, converting that to a text, assigning that text to the text object. And then we're also placing these text objects to be where the objects are. And we're done. That is how you use loops in animation nodes. And just like I said before, the cool thing now is, since we have this subprogram, we can invoke it not only here, but we could also duplicate this and invoke it somewhere else in our node tree. You know, we can reuse it as many times as we want. We can even take this subprogram here, all of these nodes, move them to a different node tree so that they're not even in here. And all we have here then is this invoke subprogram. That makes it very nice and clean, and we can organize our node trees with groups and loops. I hope you enjoyed this video. If you have any questions, write a comment below. Don't forget to like and subscribe. You can download the blend file of this and many other tutorials from patreon.com/ChrisP. Thanks for watching. See you in the next episode. Chris P. out.